Hey, welcome to my very first pro episode. I want to thank you for getting a subscription as it makes content like this possible. All right, let's dive in. In this episode, I wanted to run through a bit of a crash course on the terminology and tooling involved in running a large scale production container stack. This can be a complex topic, so here's a bit of a brain dump on how I make sense of it all with a map included. What you're looking at is a map that highlights the major functional categories that exist in most container stacks, highlighted in green here. These include things like version control, continuous integration, orchestration, logging, monitoring, etc. Then, revolving around these major category areas are popular tools that enable these types of wanted functionality or workflows. For example, GitHub is extremely popular for version control, Jenkins for continuous integration, or Kubernetes for container orchestration. You get the idea. But why create a map like this? Well, I wanted to give you a big picture view of what a complex system looks like, because individually these tools can be incredibly confusing for the uninitiated, as they often have strange names and in isolation their functionality oftentimes makes no sense. To make my point, let me run a couple phrases by you that you might hear when you're maybe reading up about containers, or maybe you're watching a conference talk. So here goes. Yeah, we're using Zipkin for distributed tracing. Oh, yeah, we're using Zookeeper for service discovery. Or maybe, hey, we're using Istio as our service mesh. Hopefully, you're starting to see what I'm talking about. If you don't have a good mental map of how things are connected, this just doesn't make sense without the larger context. This is why I wanted to create the map and sort of act as a tour guide as we walk through it. But I wanted to point out this is different from, say, a vendor specific reference architecture diagram, as we're looking at this from a higher level. My goal here is to help you get more of a general sense of how things work versus a very specific use case. So we're going to walk through step by step not only what the major functional categories of tooling are, but more importantly, why people are using them. To understand this better, it might make sense to maybe back up for a second, as I wanted to focus on what's driving companies to choose this type of production stack. This will hopefully give some much needed context into why people are doing what they're doing here. So I've created a diagram with 3 example companies. First, let's say we have a small business that's running a company website. For the sake of this example, let's say it's a car dealership, and they're hosting a fairly simple website with information about their business and car inventory. This website's likely run by a single tech person that probably looks after the office, desktops, printers, file server, along with the website. The website's likely running some type of LAMP stack, and it's hosted on a cheap hosting provider. Okay, our second example is we have an internet startup. Let's say they're doing audio transcription. The idea is that you can upload files, they'll process them, and return a text transcript. They're totally in the cloud, they have lots of developers, and they have a small but powerful DevOps team. They're totally focused on staying alive as a company, keeping bills super low, and they're trying to outmaneuver their competition. This is probably a very typical example of a startup. In our final example, we have a megacorp in the media and entertainment industry. They are not at all in the cloud. They have their own data centers, and most of their developers and operations staff are contracted. These type of companies typically have tons of legacy application baggage. They've acquired lots of different companies, and their infrastructure was typically mashed together when they went through the acquisition process without a lot of refactoring. The result is it's a total rat's nest, and they're paying hundreds of millions of dollars in ongoing software licensing fees, and they're running a mission-critical enterprise. As you can see, we quickly escalated the complexity here, but the chances are that you'll find yourself somewhere in the spectrum of these companies. This is why giving advice about container adoption is so hard. The needs of the example car dealership versus the megacorporation are so massively different. Advice you give to one would be crazy to give to the other. So, should you adopt this type of stack at your company? Honestly, it really depends on your current and future situation. In the car dealership area here, it would be totally overkill. Sure, it might be kind of cool to learn these new tools, but you're likely way better off with some sort of hosted container platform as a service, maybe Heroku or App Engine. What about the medium-sized internet startup here? Well, I'd really wonder how they're doing things today without containers. Maybe they're using something like AWS and have a pretty good system worked out with instance group and autoscalers. You'd really have to look and see what the pros and cons are. Are they really going to save money? Is this going to drive better utilization if they use containers? Maybe if they break things down into maybe say microservices for better performance. It's highly dependent on their current situation. By the way, I totally don't recommend anyone start off with microservices. You're way better off just containerizing your application into sort of a monolith and then figuring out where to go from there. What about the mega corporation here? Oftentimes you wonder what the heck these companies actually look like on the inside. Well, it sort of looks like what maybe the startup infrastructure looks like, but in their own data centers using technology from maybe 10 years ago. Okay, maybe not that bad, but it's close. Plus, there's maybe 100 times more applications of all different types. In my opinion, this is where containers can really save tens of millions of dollars a year through consolidation of infrastructure and getting rid of extremely expensive maintenance contracts. But again, it sort of takes the willpower to see a big change like this through. So I guess the answer to the question of, hey, should I adopt containers is it really depends. There's just so many options to choose from a hosted platform as a service like Heroku to App Engine, all the way to a totally open source system that you've wired together running in your own data centers. You'll likely need to do the research on your own to figure out if it's a good choice. But I've put together some questions that maybe you can think about, and it might lead you down a particular path. Now, a lot of these are pretty basic, like what are you doing today? What does your current environment look like? Hey, are there any burning fires that containers could really fix? You also need to think about sort of the larger picture of maintenance contracts. Do you have any agreements with, say, Red Hat or Microsoft? In that it might guide you down a particular solution path. I guess budget is obviously a big one. If you're a small car dealership and you're only expecting to pay $100 a month for hosting, that's quite different than someone who's spending hundreds of thousands of dollars a month. Are you running Linux or Windows? There's also a lot of sort of team stuff that comes into play here. If your team has a bunch of training on AWS and you want to move to some other platform, you're going to have to retrain, and that's a lot of work. I'll probably leave it here and that you can go through these questions yourself if you're interested. But the sort of theme of what I'm trying to get at here is that the answers to these types of questions will often lead you down a particular path, and that we don't dive into the details of a particular, say, AWS solution versus an OpenShift solution. In that if we keep it high level enough, it should be abstract and you can sort of see the core functionality and you can relate from one platform to another. Let's jump back to the containers in production map I was showing you earlier. I really want to stress that you should focus on these tool categories, as it doesn't really matter the platform you end up using, they'll all likely have something that looks very similar in terms of functionality. This applies to platform as a service offerings too. All right, let's start from the ground up here. First, let's start with host hardware. Depending on the solution you choose, you'll likely have to look after some type of hardware. This might be virtual machines backing your cluster or some type of bare metal sitting in a data center. My personal preference is to have everything in the cloud, as you can really scale up, and hardware issues are pretty much a non-issue, as you can just fire up new instances to work around the problem. Next, over to the side here, I added infrastructure automation tools. I recommend infrastructure automation tools like Terraform because it comes in extremely handy for automating the setup of cloud infrastructure pieces in a repeatable and consistent manner. If your container platform doesn't already do this for you, and you're using something Terraform supports, like AWS or Google Cloud, I'd highly recommend checking it out. I think of Terraform very much like configuration management for cloud infrastructure. Basically, you're creating a script that defines step by step, hey, I want you to go and build these particular pieces of cloud infrastructure. Things like, hey, setting up a load balancer, setting up compute instances. Hey, I want my network to look like this, that kind of stuff. So if you're going to do manual things over and over, it's probably worth investing the time into building out some sort of Terraform scripts. Next, let's chat about the host operating system. If you're going to be running things yourself, typically you're going to have some sort of stripped down, minimalistic Linux operating system with just the essentials to get you going. This might be RHEL for OpenShift, or maybe Ubuntu, or maybe a stripped down, containerized, optimized image for Google Cloud. CoreOS lives in this area, same thing with Rancher. Most of the time, cloud providers will look after the base OS for you. Maybe not necessarily manage it, but they'll have some sort of scripts that will bootstrap the image for you. This kind of plays us into the configuration management area here. If you're running things yourself, you'd often run configuration management to make sure that each system is very similar to each other. Basically, you're stamping out these worker nodes. But it really depends on the solution that you choose. Again, if you're using a cloud provider, they'll typically look after this type of stuff for you via some sort of init script. But the core idea is that you want all your systems to look the same, as they are essentially worker nodes just running your containers. All right, we're getting into the good stuff now, container orchestration. But what does that even mean? Well, the general concept is that we have some containers and we want to give them to this orchestration program, something like Kubernetes, and have that orchestration program manage the lifecycle of those containers. As you can see, it's a pretty crowded space. I didn't even add all the various tools that you can use. But in my opinion, Docker and Kubernetes are pretty much the clear winners here. And that's kind of evidenced by pretty much all cloud providers having a Kubernetes offering. So no matter where you want to run this, you can likely do it. These types of tools are very much the heart and soul of your container production platform. However, you need a lot of these supporting systems like continuous integration, logging, and monitoring to really accelerate your workflow and sort of make these systems fly. So let's move on to a couple other supporting systems. Things like service discovery. This sounds sort of complex, but it's actually a really simple concept. We all understand DNS. You use sysadmincast.com and got my IP address, and that's how you're watching this video. That's service discovery. However, container systems often need something a little bit more specialized, since they might need an IP address and a port, rather than just, say, an IP address with DNS. Containers also make it extremely easy to scale up and down your application, so you might need a high rate of requests per second for a very specialized query with no caching. That's why these tools exist. Basically, think of them like specialized DNS for containers. Obviously, that's simplifying things, but that's it. Another supporting service is a category called secrets management. So we're all going to run applications that, say, require API keys, or have embedded passwords, or maybe we're using an SSL certificate. How do we deal with these type of secrets? Well, the practice is that we want to load these secrets into something called a secret management solution. But the kind of concept is that we don't want to embed these secrets within a Docker file. When the container needs access to a particular secret, it's going to ask the orchestration system, hey, I'm looking for this password. And if it's granted, it will hand it over. They appear within the container typically as an environment variable or maybe as a mounted temporary file that your program can read. Then when a secret changes, you don't necessarily need to go back and rebuild a whole slew of Docker images. Or if someone gets a hold of your Docker images, they can't extract the secrets. So it's sort of a convenience thing, but also very much a security thing. Now that we've covered a pretty high level overview of the core platform for running containers, let's jump over to sort of the ingestion point, or how we'd actually deploy containers into this production environment. On the desktop side, we're going to use things like obviously a web browser, text editor, SSH, and Git all the time for interacting with tools in the various categories. Maybe you'll be checking in Docker files that build some container images, and these get pushed out via some automated method to the orchestration system. I just wanted to mention that it's quite common to interact with tools in all of these various categories. For example, you might be logging into your cloud provider to check the underlying host performance. Then you're logging into the logging and monitoring systems. For a lot of this stuff, it's sort of set it up and forget about it and only check on it if something breaks. But on most of these platforms, you totally have the capability to log in directly and check all this stuff. Next up, there's version control. I honestly don't think this needs much explanation. However, you will typically configure some type of notification on code submission called a webhook. This is used to trigger or notify other systems automatically that something needs to be done. This is a great example of how Jenkins is often triggered. Speaking of Jenkins, this is where continuous integration kicks in. But let's back up for a second. Say you're a software developer and you're working on some code on your desktop. You check that code into version control. This kicks off a webhook to Jenkins. Jenkins then checks out your code from version control. It quickly runs through all your tests that you've built into your code base. It compiles your code, builds a Docker image, and then pushes that Docker image to the Docker registry. Obviously, this is sort of a best case scenario. You need to configure all this, but it works as a good example. Your Docker registry is used to hold your Docker images. You could use Docker Hub, but it highly depends on where you're running containers and what your production setup looks like. For a lot of companies, they don't want to host their private intellectual property, say, up on Docker Hub. So they might use something like a hosted registry within their production environment. That way it's super fast and they have complete control over it. Okay, just to recap. So we checked our code into version control, it was tested, compiled, and a Docker image was built. Then it was pushed to the registry. But this is where things get a little interesting. Many people just use Jenkins to fire off some sort of automated deployment or custom script that will automatically do something here. This is what continuous delivery typically means. Hey, I have new code and I want to deploy it into production. Send it over to the container or orchestration platform. There's all sorts of fancy tools that go into this category, but oftentimes you'll find simple scripts connected to Jenkins that are actually doing the work. But there are tools like Shippable. Say if you had a large scale production environment with tons of different pipelines and you wanted to do all sorts of scheduling and rules, that's where you'll find tools like this. And they can be really useful. So at this point, we have our example application sent over to the container orchestration platform, and it's happily running in production. But now what? This is where the logging and monitoring categories come into play. Say you have a container that has a high amount of traffic hitting it, so you scale the container up to 10 instances. Now you basically have 10 programs all streaming out logging information, and you need to make sure you collect that. So there's tons of different tools in the logging category that can help with this. Oftentimes I just use something built into the cloud provider, or maybe Elk, but this can be a pretty critical thing for helping you debug problems or verify that things are working as you expect. Next, we have this monitoring tool category. This plays into the idea of making sure things are working as you expect. You might take a lot of the log files that you collected and run them through some script to verify you don't exceed some rate limit or timeout limits or something like that. For me, the lines are a little bit blurred between logging and monitoring tools, as you often have them very tightly coupled and they work closely together. Just a couple more and we'll wrap up this episode. So the next one I want to chat about here is load balancing. So now that we have an application running, you'll likely want to route some traffic to it. So load balancers come in handy. It seems that each container orchestration tool has its own flavor of load balancing. But the general idea is, say, hey, we have 10 instances of a container running and we want to route traffic to it. How do we do that? Well, we need a load balancer. So Kubernetes supports its own version, Docker Swarm does its own version, but also cloud providers sort of implement their own versions using their custom sort of platform load balancers. So it really depends on where you choose to host your container production platform. Generally, the idea is the same. Hey, I want to put a load balancer in front of all my containers and I want to route traffic to them. If what we've covered so far isn't enough, there's all sorts of container and microservices tooling that can be used in conjunction with these tool categories. For example, Istio can be used as a type of proxy, also called a service mesh, that basically wraps your application and can do encryption and smart request routing. I'm actually doing a demo in an upcoming episode in a few weeks. All right, so that's a quick guided tour of the general categories for running a pretty well-rounded production platform. Oftentimes you'll see platforms like this, but maybe they're missing a key category here, maybe like monitoring or something like that. But generally, this is how things are set up. One thing you might notice is, hey, I never chatted about storage. And that's because it's highly dependent on the application that you're running and also the platform that you're running it on. For example, maybe your application needs to be modified to support a particular storage type. Or maybe you need to do some fancy platform tricks to get the performance that you need out of your storage inside your container. I don't think it's something you need to be worried about. It's more of, hey, I need to be aware of it and you need to plan for it. So in all, this might look complex, but honestly, most cloud providers have these type of offerings that you can get up and running in a matter of minutes to say hours. The cool thing about this setup is that once you have it up and running, it's mostly automated. Any future projects can just take advantage of this new platform for free. You sort of hit this threshold where it makes sense. It's sort of economies of scale of application hosting. If you're just running one simple application, maybe this doesn't make sense. But if you're running multiple applications, this platform looks more and more attractive. Okay, well, hopefully you found this episode somewhat useful. I can pretty much guarantee you that anyone who's running containers in production at a larger scale has something that looks very similar to this. They almost certainly have all these categories covered. So now you have a common ground for understanding what other people are doing, and it's sort of generalized or applies to multiple different environments. The map is also available on my website. You can access it via the top navigation bar. All right, that's it for this episode. Thanks for watching, and I'll see you next week.